All right, so we're reaching the end of the chapter. This is going to be the last video of chapter 2. And it's just something that we have to go over somewhere, and I thought this was probably the best chapter to put it on while we're still kind of building up some fundamentals. We have to go over redox reactions and oxidation states to make sure we all have this knowledge and are on the same page. And so just to remind you, redox reactions are reactions in which there's an electron transfer event, one or more electron transfer events. The word redox comes from reduction oxidation reaction. It's just a shorthand way of saying that. Reduction, remember, is gain of electrons. Oxidation is loss of electrons. And if you're having trouble remembering that, you can use the following two mnemonics. Leo the lion says Gur, loss of electrons is oxidation, gain of electrons is reduction, or oil rig, which is the one I use, oxidation is loss, reduction is gain of electrons. So here's an example of a redox reaction, reacting calcium metal with calcium chloride. That's going to be a pretty spectacular reaction. Reacting calcium metal with chlorine gas to make calcium chloride. That's going to be a pretty spectacular exothermic reaction, giving off a lot of light and heat. But anyway, what is going to happen there is, calcium chloride, if this is in aqueous and some water, is going to dissolve, right, to give calcium 2+ and Cl-. So you can see that you have two neutral things and then you made a cation and an anion. And so there had to be some electron transfer if you went from neutral stuff to charged stuff. In particular, what happened is calcium was oxidized. You lost 2 electrons from it to make the calcium ion, and the chlorine was reduced to go from neutral chlorine elemental to chloride. And overall, you could add these reactions up, cancel the 2 electrons, and cancel cancel the 2 electrons, and then combine the ions back into the ionic form of the compound, and you get this overall reaction. So really important thing that you have to really expect you to know and do very well at doing is assigning oxidation states. Elements in pure compounds are going to get an oxidation state of 0. Monoatomic ions, it's going to equal to their ionic charge. Fluorine in all of its compounds is always going to be -1, except when it's an element. It's not a compound then, it'll be 0. Oxygen in most of its compounds is going to be -2. Where does this come from, right? Because oxygen wants to become like neon, fluorine wants to become like neon. Except for peroxides, oxygen is -1. Hydrogen in covalent compounds is going to be +1. In ionic compounds, it's as a hydride, it'll be -1. Most of the time, you're going to see hydrogen in a covalent +1 form. What is the oxidation state? Let's do some practice for this. Oxidation state is just a bookkeeping method to keep track of formally where the electrons are going, what's losing electrons, what's gaining electrons, and sort of how many electrons sort of belong to each element. Okay, so magnesium is in its elemental form, so that is going to be 0. Water, remember, oxygen is always -2 most of the time, except for peroxides and compounds. And so water is a neutral molecule, so that means each hydrogen is going to have an oxidation state of +1 to balance it out, because 2 times +1 minus 2 is 0. So overall it's 0. Here, hydrogen's in a covalent compound. It's not a hydride, so it's going to be +1. Oxygen is -2. You know that the charge of hydroxide is -1, so -2 + 1 is -1, so that checks out. And you have 2 hydroxides here, so magnesium is going to be +2. You can also know that because magnesium is a 2+ ion, so it's going to be +2. Hydrogen is an elemental form right here, so all elements get 0. So what's happening? Well, magnesium got oxidized in this reaction, went from 0 to 2+, went up, so it gained an oxidation state. That means oxidation occurred. It was oxidized, and hydrogen was reduced. Its oxidation state went down from +1 to 0. Okay, let's just do another practice. So here's one, iron in its elemental state, oxygen in its elemental state. Both of those are going to be 0. Here's iron oxide. Oxygen in most of its compounds is now -2, so it's going to be -2. And for this to be neutral, the iron is going to have to be +3. because there's 2 irons, so that's total +6, and there's 3 oxygens, so that's total -6. So overall, it's 0 because it's a neutral compound. What happened? Iron lost electrons because it went from 0 to +3. It got oxidized, so oxidation occurred. Oxygen got reduced. It went from 0 to 2-, it gained electrons, so reduction. There's some terminology that can be a little confusing with this, but it's very common that I will use this terminology later in the course, and other people will, just because it's kind of so deeply ingrained in chemistry. An oxidant is something that gets oxidized. Let's do oxidizing agent next. This is probably the most common one of these used, so very important to use. It has an high oxidation state, and it lost many electrons, but now it can be reduced. So the oxidizing agent is going to do the oxidation on something else, but it itself can be reduced. So the oxidizing agent is what can be reduced. So here, oxygen is the oxidizing agent. It got reduced, but it oxidized iron, right? Iron is the reducing agent. It got oxidized, but it reduced oxygen. So there's reductant, also there's oxidizer. Oxidizer also means the same thing as oxidizing agent. So you could call oxygen here an oxidizer or an oxidizing agent. Most of the time, we'll use the term oxidizing and reducing agent. Those are really important terms. Antioxidant, that's something else that you probably have heard of. This is something that gets oxidized instead of something that you care about. So, why is vitamin C so good for you? Or why are these, other antioxidants so good for you? It's because they're getting oxidized instead of your DNA getting oxidized, which can be bad, or other parts of your cellular structure that are important. Okay, so that's it for chapter 2. I'll see you on the chapter 3 videos.